title of my paper is DraftNet, a real-time recognition system for traffic signs, and myself and my co-author Anshul have done this paper. So the presentation flow would be like introduction, dataset description, the models which I have used, results, and conclusion. So let's get started with the presentation. Just a second. Just a second. Introduction part. So the motive behind this paper is like many times there are a lot of traffic on the road and we have some traffic signs, and it might be challenging for the what do we say, the drivers to see around and focus on the road simultaneously to see the signs and follow according to that. So keeping in mind that problem, we have decided and proposed a end-to-end automated model for the same. Like my screen is visible, no? Just to confirmation. Hello?
Yeah, please go ahead.
Okay. So that was the thing. So main contributions that we have done is proposed a real-time end-to-end traffic sign recognition system, which captures videos and outputs the recorded sign through the vehicle's audio system. Trained and tested various machine learning and deep learning models for recognition of traffic signs. And along with that, we have fine-tuned the model and verified it using several hyperparameters to increase model's accuracy and efficiency. So let me explain the basic flow of the automated system that we have proposed here. Initially, using the webcam or anything, it will be the car's webcam. We will capture the traffic board signs, and using object detection, that sign would be captured. That sign would be passed to the machine learning model, and it would be recognized that what is the sign. And after that, we have created a file simultaneously, according to which it will convert it into sound. Like if it is 50 kilometer per hour sign, so it shows that the speed limit is 50 kilometer per hour, that would be converted into audio, and through the car's audio system it would be there for the driver to see, to watch. And so here, this is the basic flow what we have followed over here. Now the data set which we have trained on, it is an openly available data set on Kaggle with approximately 73,100 photographs, and it covers 43 different classes of photos and the traffic signs. Initially, the data set was imbalanced, so we changed it and augmented it according to our own need. Now, let me introduce to the models that we have used for training. Like initially, the first one that we have used is DenseNet architecture model. This is the whole architecture of DenseNet: input layer, blocks, convolutional pool layers, and how it works. It actually has 201 hidden layers, and it is connected at 16, a con layer into 16. This is the whole architecture. Then second, we have the mobile net model. As shown that initially what it will do, it will have a lot of convolutional and depth-wise and convolution and other convolution. It is a very light model. So this is the mobile net model. Thirdly, we have used CNN architecture. This was designed by us own according to our need, like what we needed, dense layer, which layer we needed, max pooling and everything. Then the efficient net architecture. Here in all the models, we have used transfer learning and modified it according to our own needs, the size and output. And finally, the ResNet with the ResNet architecture. Next, coming on to the results. So the best accuracy we achieved using MobileNet, that was 99.72% on the dataset which we have trained. Others also gave a very good accuracy. Efficient net, ResNet, and all these are like ResNet gave us 99%, CNN gave us 98.3%, but the best was for MobileNet. In the conclusion, I would like to say that in order for drivers to learn about the traffic signal, this study offers a real-time end-to-end system to recognize traffic sign boards and translate them into voice. And the main thing that we have proposed is like it is very effective, low cost, and easy to employ because audio system and cameras are already installed in the cars. We don't need a specific device, just a new functionality of the old system, I would like to say. Best accuracy we have achieved is 99.70%, which is very nice. And it would help drivers to drive more safely and pay more attention to the road rather than looking here and there for the traffic signs. This was the whole motive of our work and what we wanted to present to this conference. Thank you.
Nice to meet you, everybody. My name is Dr. Niveen Guler.
Yeah, visible. It is visible. Please go ahead.
Okay, can you hear me?
Yes, yes.
Yes. Okay, great. My name is Dr. Niveen Guler. I'm an assistant professor at the University of Technology, Bahrain. Today, I'm going to present our research paper with my co-author, Dr. Ali Gunesh, entitled Optimal Resource Allocation Scheme Based Time Slot Switching for Power for Point-to-Point, Single Input, Single Output Swiped Systems. First, I'm going through an introduction to the main concept along with the motivation, and then the system structure with the proposed algorithm, and then the simulation results, and with the conclusion and future work. So as an introduction, energy shortage is one of the critical issues that degrades the network performance lifetime of wireless sensor network, where a large number of sensors are empowered with limited energy that is difficult to recharge or even replace. So in this context, harvesting energy becomes a promising solution for reducing the energy consumption and extending the lifetime of the energy-constrained wireless sensor networks by allowing the sensors to harvest the energy from the surrounding environment. Simultaneous wireless information and power transfer is among the energy harvesting technologies where energy harvesting is done through the radio frequency sign, where both information and electromagnetic energy are carried simultaneously. Time slot switching, TS, and the power splitting, PS, are two techniques used in this swipe. So most of the state-of-the-art swipe system considered the linear energy harvesting model, where the power conversion efficiency factor of the energy harvesting receiver is assumed to be constant. Yet it is found that the power of the RF to the direct C converter shows saturation behavior when the input power is above a certain threshold. Therefore, the energy harvesting model based on a linear assumption does not properly model the real characteristic and may lead to a resource mismatch in the resource allocation or the overestimation in the system performance evaluation. Therefore, the proposed scheme considers non-linear energy harvesting point-to-point, single input, single output swipe system based on the time slot switching, aiming at maximizing the average achievable rate. So we consider a single input, single output point-to-point swipe communication system with TS receiver as in figure 1. The information transmission block T is divided into n time slots. We assume that each time slot is used for either information decoding or energy harvesting to the optimal scheme. The optimal problem is formulated as a non-convex optimization, which we prove to meet the time sharing condition. And then we solve the problem by using the time sharing strong duality theorem and Lagrange dual model. So in each time slot, the time switching ratio tau is equal to either 0 or 1, indicating that the receiver implements either the energy harvesting or the information decoding. So the received signal is given by equation 1. Accordingly, the achievable rate is given by this equation again, and also the harvested power at the receiver is given by equation 3. And here, accordingly, we formulate the harvested energy, which is given by equation 4. So the proposed optimal resource allocation scheme maximizes the average achievable rate, is given by equation 5. So as it is seen here, it is not straightforward. It's a combination of a non-convex problem due to the binary aspects of tau, so it is difficult to solve. In addition, the complexity also increases as the number of slots increases. Accordingly to the time-sharing strong duality theorem, the primal problem has the same optimal solution as its dual problem. Therefore, we found the language dual function, which is given by equation 6. Accordingly, the dual language dual function is given by equation 7. And then the dual problem is given by this equation 8. In order to solve equation 8, we have to decouple equation 7 into n parallel subproblems, given k from 1 to n. And we formulated the formulas in order to have the optimal solution tau given by number 12, equation 12. So hence, for a given value, we can find the tau, and accordingly, the optimal dual variable is found by iterative solution. First, we consider here two functions, which are the channel power gain, G1 and G2, given by equation 13 and equation 14. As it is seen by equation 13, it is a combination of logarithmic and linear function. How solving it is not straightforward. Therefore, we transverse the value of h from 0 until the difference between the first part and the second part becomes very small. We set it to 10 power minus 6. Accordingly, we found G1 of h and G2. So the H1 and H2 is given with the range, okay? And accordingly, when H is between H1 and H2 and so on, the optimal TS strategy is given by this formula. So tau is converted into according to the SNR. So it is 1 when H less than H1, or when it is greater than H2. And if it is 0, if it is in the medium range, in between. So accordingly, we formulated the average energy collection by equation 16, and algorithm 1 summarizes the iterative search for the optimal dual variable lambda prime, which is given by table 1. Okay, and then table 2, which describes the optimal resource allocation scheme. And accordingly, we found the results, which regarding the average energy efficiency with the transmission power. As we can see, the transmission power, as the need increases, the efficiency, energy efficiency decreases. Here we can see that the SNR, when it is small, the gap between our proposed scheme and the traditional state of art is not that big. But when the SNR is in the big range, let's say 15 or 25 dB, we can see that the gap is big because of the saturation of the energy which we considered. And here we take our proposed scheme, take into consideration this, whereas the state-of-the-art schemes, the power is thrown away, just like thrown away, not being used efficiently. And the same thing, the average energy efficiency regarding with the distance, and the average energy efficiency regarding with the minimum required harvested power. We can see in both figures that the proposed scheme outperforms the state of the art. And regarding the minimum required harvested power, as it is increases, we see that the energy efficiency decreases for the other state of art, but for our proposed scheme, it's almost unchangeable. It's almost fixed due to the saturation. So as a conclusion, in this paper, we have presented an optimal resource allocation scheme for the point-to-point single input, single output swipe system with nonlinear energy harvesting. So our proposed scheme is based on the TS to maximize the average information rate, where the performance is recorded as 20%, 10%, and 3% better than the other state-of-arts algorithms. Therefore, we have also investigated the impact of the minimum required harvested energy on the average energy efficiency performance. It is demonstrated that the average energy efficiency decreases with the increase of the minimum required energy, harvested energy for the traditional TS allocation scheme, whereas it is hardly affected for our proposed scheme. This is for today's presentation. Thank you so much.
Good afternoon, one and all. Thank you for giving us this opportunity to present our research paper on the topic examining the performance of NLP language models, a comparison study. So I'll introduce myself. I am Palash Rambia, currently pursuing my BE in Information Technology at DY Patil College of Engineering, Pune. So let's get into the paper. So first of all, the paper talks about comparing different language models, that is GPT, which is in the current boom. BERT is yet another, you could say, language model that we have compared, and the third one is Macaw. So transformers are used in language models, many language models, as we know, like GPT, BERT, Roberta, Macaw, etc. And language models learn from huge data sets of human languages to generate the natural language text we get. So as we know, like we input data to GPT and we ask questions to GPT, and as it is a generative model, we get different outputs and different answers from the same. Similarly, BERT is an encoder model, so it gives it is a context-based model, you could say, which gives answers based on context it is provided. And we have Macaw, which is a meta-learning algorithm, which is yet in the development phase. So these models represent important advances in natural language processing, and they significantly improve the performance of on various language-related tasks as well as our day-to-day tasks, and they have significantly improved the performance. Going to the papers that we have referred in our review paper are some of these papers which we have been through, and we have discovered many different algorithms which we have come across during reading these papers, and we have included those in our review paper as well. So before starting on methodology, I'll transfer the presentation to my author.
Yes, hello everyone. I'm Arya Gaikwad from Department of Artificial Intelligence and Data Science of DY Patil College of Engineering. Starting with our methodology, we have a first question. How did we compare the effectiveness of different models for specific language related tasks? Basically, we have the idea that how and where the language models are used, specifically in chatbots or in text generation. For our review paper, we have considered three types of questions on which our language models have been examined. The questions which we have divided it into are of three criteria, that is factual questions, healthcare questions, and futuristic impact of AI. Starting with the factual questions, the reason we have selected factual questions is basically to understand the vast knowledge and accuracy or reliability or the general knowledge of any specific language model. Going with healthcare, we do know that we have chatbots in different healthcare applications. Now, how these language models will perform on specific healthcare tasks, the effectiveness in understanding the specific medical terminologies is examined in our paper. And the last criteria which we have selected is impact of AI. For impact of AI, the main consideration we have is ethical consideration, the potential bias any language model can show, the risks and challenges of AI. Moving on to our next question, we have did we consider any other language models? So everyone, we kind of know that GPT is we know about ChatGPT. So ChatGPT specifically uses the GPT language model. GPT language model and BERT, both of them have number of applications. Like GPT, we have ChatGPT or any other open AI platform is tuned with GPT models. And for BERT is developed by Google developers. And so basically in search engines of Google, BERT is used. The last model we have selected is Macau. So why Macau? Because in a paper it was shown that Macau on specific questions was able to perform better than GPT-3 model. The next question will be effectiveness of each language model and how they are going to contribute in the field of NLP. So every language model is every language model basically is trained on a huge data set, and that's why it's able to perform on any NLP related task. The main aim of language models is accessing specific challenges in NLP and address real world challenge and practical applications. Now, how can our in what ways can our methodology be improved or expanded upon in future research on language models? As we have taken some general questions every, which any chatbot will be able to perform on. But if you want to extend or expand upon this research, you can go in specifically for medical or even mathematical questions. Now, moving on. So, first, as I said, we have factual questions. Here we have the result, that is, we have given some questions, and like this is a few examples of the questions we have selected. What is the capital of USA? We can see that GPT is able to answer, while Macau is saying that it's unknown. For BERT, it is giving a specific answer, which is Washington DC. Moving on, we have the longest river. Then in that GPT is able to answer that it's Nile. But while Macau is answering it incorrectly, that it's in same way we have for medical questions. Now, GPT, we have two parts in the first question. We can say what is tuberculosis and its cure. So, for what is tuberculosis and its cure, we can see GPT is able to answer that tuberculosis is a disease, and while it is even able to tell that how it can be cured with help of antibiotics. But Macau is only answering it in a short form, which is TB is kind of a disease. We'll move on to the next slide. As Palash earlier said, that BERT requires context for answering every question. If we are giving it a question, we need to give it a proper context so it's able to perform on that. And for this reason, we tried giving context to all the three language models, GPT, Macau, and BERT, and check its performance on this. This criteria was for impact of AI. We'll move to the next slide. Okay. Finally, coming to the results, the availability of the models. GPT for GPT, it is provided by OpenAI. You have to purchase it, or and they will provide you a specific API key. It is not an open source project. Macau is an open source project, but it's not kind of trained on a used data. So basically, uh, it's not recommended. It's not recommended for its use in um, a wide audience. And then going on to the next, we have BERT. BERT is a open source language model, and which is readily available. BERT has kind of three models. Sorry, BERT has different kind of models which is pre-trained, and we can access it on even Hugging Face. Next on moving to the performance, GPT is able to perform well on our question and answering task, and it gives, as we saw, that it gives a detailed answers to all the questions. Macau does not perform that well compared to the other two models. It may sometimes give you unknown or incorrect answers. While for BERT, it works well, and it's more accurate, as every time you're feeding a context to it, the information or the context which is feeded is actually helping the bot to give a specific answer for it. Then in the learning process, GPT, we do not require context. For Macaw, also we do not require context. Macaw is a it is trained on multi-angles. So like while providing it, it is possible that we can give the Macaw, we can give Macaw input as in we can also give it, provide it with the question, answer, slots and options. That is why it is called as a multi-angle training. For BERT we have to give the context every time, and if the context by mistakenly becomes wrong, even our answers will be incorrect. Now, as we can see in the graph, we have factual questions, healthcare questions, and impact of AI. In factual questions, GPT-3, which is given by the green graph, and bot is given by blue, while the macaw is given by red. For GPT-3 is performing well on factual questions. Macaw is not performing that well on factual questions. Then going to healthcare. In healthcare, we can see that Macaw is actually performing better than GPT-3 model. And for our next impact of AI, where we have provided context to all of the models, GPT-3 is performing well, followed by BERT and then by Macaw. Yes, so basically the conclusion is that GPT-3 gives us a wealth in-depth answers, and it is able to answer majority of the questions. For Macaw, it's giving short answers, but sometimes they also may be incorrect. And going with BERT requires context and it provides accurate answer. Yes, I'd like to thank everyone for giving us this opportunity.
I am Bhuvan Shikanta, and I am pursuing my computer science degree in PS University, Bangalore. I am a final year student, and me and my team have done the paper on a donation monitoring system using blockchain. So, as we all know, in the recent years, there has been mostly a positive perception on charities and NGOs, and but also, as we know, there is a wide consensus among the people and the public that the charities and NGOs are not as transparent as they seem to be, and there might be some scams or tampering of the users' data that is happening there. So, how to solve this problem? So, we thought that we could use blockchain as a promising technology for these problems, and use blockchain to promote transparency in the charity donation platforms. So our aim is to create a platform where users can clearly see who is receiving the funds and they have donated, and the transactions can be tracked from which receiver's wallet it is being donated from the donor's wallet. So we are basically trying to remove any third-party involvement during these transactions, and provide a hassle-free experience to the customers so that they don't have to face any adversities. So this project will help increase the accountability of charity organizations, as all the transactions recorded on a blockchain network are immutable and public, so anyone can access the records. So, and it also helps strengthen the trust of people in charity organizations, and our intention is to track donations from donor to the beneficiary directly, so that there won't be any mishappenings or any scams or anything like that. So, and this project steers strictly clear from the model of crowdfunding, and thus there is no issue of exceeding the amount. If a request is posted, only the specified amount will be donated to the requester. And yeah, next, let's see the requirements and design of this project. So we are planning, we have done a simple Ethereum based donation monitoring D app. So now only we are using Ether or cryptocurrency as the basic medium of exchange. And so the nature of cryptocurrency additionally encourages transparency, as I've said before. So anyone on the blockchain network can clearly see who is making the donations and who is receiving the donation. And this way, all the donors can have a peace of mind about where their money is going, and they can track it anytime, anywhere they want. So, and our DApp can be thought of as a combination of three parts. The front end, we have used Vue or Beautify to do the front end, and blockchain. So blockchain, of course, blockchain is acting as a back end here, and middleware, the main logic will run the application. So this is a model architecture. So the donors, first of all, the receivers, they post a request, and the donors donate, and through a charity pool, through a proper digital wallet with a ID number, the money can be transferred to the receivers. So here the receiver makes a request, and it will be verified, and then only upon verification, the donor will see the request, and then he'll donate the required amount, and he'll also receive a unique ID through which he can track his donations. So here, after a request is posted, the donor sees the request. After the request has been legitimized, the donor basically donates the amount with the tracking ID, so that he can see where the money has donated goes throughout the network. And we are hosting this on a public blockchain platform like Ethereum. So we have made use of smart contracts. So basically, smart contracts removes any third-party applications. It is an automation of the transaction. Basically, it will be used to handle all the transactions. Only verified users will be allowed to make donations or receive donations to prevent any form of frauds. And yeah. And one more layer of verification, we have added a CAPTCHA verification, so that any bot or non-humans can't pose a request and act like a human. So this is a simple CAPTCHA verification that we have tried to implement as an extra precaution to any frauds or scams like that. So this is basically small prototypes screenshots. So here you start press on start a project. Then you give the title and description and the amount needed. Right now we are only using Ethereum as the currency, so you have to put it in ETH, and the duration, like what time duration you need, and you have to post the request. And then the this right side, this is a MetaMask wallet through which you can donate the post request amount. So this will be the confirmation button, and once you confirm the project, so this will be the interface. So here there's an ongoing request. So here people can donate how much ever the goal amount is. Here the goal amount is 100th. As of right now, like only 40th has been donated. After 100th will be reached, the donations will be stopped by accepting. Like there won't be any more donations accepted. And then this is a expired project basically. So if the donation amount is not reached within the set amount of time, the project will be expired, and people won't be able to make any donations toward the project. So what are the technologies that we have used to build this DApp is, first one, obviously it is Solidity. So it is an OOP language which we have basically used to on the Ethereum platform for implementing the smart contracts. So we have used it on the back end part of our application, and Vue is for the front end. It acts as a JS framework, so, and the user to build a tangible user interface. And Ganache is an Ethereum simulator that makes it faster and easier to develop Ethereum applications. So Ganache has basically given us some of the test private keys and test networks through which we can make some donations or receive some donations. And MetaMask basically acts as an agent, basically a wallet, crypto wallet that allows us to make these transactions possible. And the outcome is we have a better understanding of how smart contracts and Solidity can be combined to make an automatic execution of the contracts without any interference. So by using cryptocurrency for donations, there won't be any form of scam or fraud, as all the transactions can be tracked easily by the public. So any exchange fees also can be countered, like an international fees or something like that. So, and as well as we can claim a deduction in taxes by making donations under Section 80G. This for Indian government rule. So they can claim a deduction of tax by making donations. And the conclusion is basically using blockchain as a technology, we can build trust with donors and recipients and different stakeholders. So blockchain-based solution can permit the charities and NGOs to deliver results in completely novel ways that might be possible might not be possible without the blockchain. So the importance of blockchain is mainly the transparency, immutability, and the public trust that we can build. And as for the future work, we hopefully can make a integration with some government form, and we can gain permission to the Aadhaar verification, basically adding an other layer of verification to make it even more secure than it is now. So thank you guys for giving.
Omkar Shinde. I'm a Master of Technology student in Birla Institute of Technology under the MTech course here with my co-authors Dr. Neeraj Kumar Singh as assistant professor, and my fellow friend Komal now is a PhD candidate here in Department of Computer Science and Engineering. So my research topic and this presentation's topic is a comparative study on sand, basically different types of sand type classification using transfer learning and average ensemble. So these are the table of contents of this presentation basically. So the objective of my research is to classify different types of construction sand using different deep learning models such as DenseNet 169, Inception, V3, and Exception, and then combining all these three to have to basically make an average ensemble learning and a weighted ensemble learning using these three deep learning models. So this is my introduction. So the construction sand basically it's differentiated based on its particle size, shape, texture, and color. And understanding these characteristics can help the construction workers and builders to choose the right amount of sand for their projects. And as we know, the sand which is retrieved from the riverbed, it needs to be differentiated as to these different sands have different work purposes. So these the sand needs to be differentiated, and we are doing that with the help of deep learning. So to improve on the human error aspect and also to save time and effort, we use deep learning models to classify these different sand into different types of sand. For example, grade 1 sand, which is the most purest form of sand, is the most fine sand, which is used mostly in plastering purposes. Then there is grade 2 sand, which is also being classified by our models as the class 2 sand. It is mostly used in construction and masonry work. And the grade 3 sand, which is like the worst among all these three, it's used for the protective layer in houses and buildings and for different purpose, as this is the most cheapest of sand and the worst sand which we won't use in our plastering and everything. So this is the literature review for my research. So these are the three types of sand I was talking about. This is the grade 1 sand, the grade 2 sand, and the grade 3 sand. Grade 2 sand is the most original form of sand which is retrieved from the riverbeds. So after segregation, we get these two sands, which is grade 1 sand and the grade 3 sand. Grade 1 sand is the most purest and the most finest sand, which is like a little bit expensive, and as compared to grade 2 and grade 3. And grade 3 is the worst sand I was talking about. So my data set, basically I collected 500 plus images from the site, such as riverbed, etc. And it was the training and testing sets were created with 70 to 30% ratio. And then pre-processing was done as cropping was done of each images into 4. Like each image was cropped into 4. And then the data set was data set size was increased, and then with various image segmentation techniques, there's a resize, and there is fill, then there is flip, image rotation, zoom in, zoom out. The image data size was increased and fed to the models. So the data set was collected from a local site near our college. So this is the DenseNet 169 model. This is the first model that I applied. Actually, we applied different models on this data set, but the three best models for ensemble was DenseNet 169, Inception V3, and Exception. So these three models gave us the best results for ensemble. That's why we use these three models. So this is DenseNet 169 models. Basically, it's somewhat different from the typical DenseNet 121 is that it has 169 layers. And as we know in DenseNet, every layer is connected to the back fourth layer and each layer. So as I was saying, the input size for DenseNet 169 is 224 and 224.3. So a customized layer was added as well, which sets the input size for a picture to 256 into 256 into 3. And DenseNet was basically it was introduced in 2017. And so why we use DenseNet is to handle the problem of vanishing gradients, as to the gradient size should not be very small. If it's small, it could hinder training. That's why we use DenseNet 169 over DenseNet 120, which is the traditional DenseNet model. Then so this is like the purpose of the transition layers is to reduce the spatial dimension, as I was talking about. And then in DenseNet 169 there is a batch normalization layer, one railway activation layer, and one 3x3 layer with a dropout layer at the end. So this is the second model we used on dataset was Inception V3 model. Again, this is a little bit improved version of Inception. We use this because there was about 25 to 30% parameters were used less, like less amount of resources were used, because what happens in Inception V3 is a 5x5 layer, a 5x5 filter, basically kernel is replaced by two 3x3 kernels, which help in less amount of use of less amount of resources. And furthermore, factorization goes on, as a 7x7 layer is also replaced. Also, like a 3x3 layer is replaced with a 3x1 and a 1x3 layer. So 3x3 is like equal to 9, and 1x3, 1 into 3 plus 3 into 1 is 6. So it's like the parameters are getting less usage. So as I was talking about, 1x1, 3x3, and 5x5 convolutions were used. So Inception V3 was way better than Inception. And this was the third model that we used was Exception model. So the exception for the default input size for Exception is 299 into 299 to 3. And it's nothing but extreme Inception, we can call Exception as. So it's very similar to Inception model, except there is a point-wise convolution and a depth-wise convolution happens in Exception model. And then we used all these three layers, all these three models actually, to form an ensemble model, which gave us the best accuracy out of these three. So the accuracy got from the ensemble learning was 98%, which was way better than all of the three models comparatively. And this is basically what the slide tells about pre-processing and everything for the ensemble model. So we did pre-processing, then augmentation for the ensemble model, and then got the results from three models, combined them, and used the ensemble. So these are the results for DenseNet 169, which we used first. It was 92%. Then Inception V3 was 87%, Exception as 89%, and finally the ensemble gave us the best results, that was 98 to 97%. So these were the confusion matrices we got for all the four models. This is DenseNet, Inception, Exception, and the last model, Ensemble. So these are basically a brief description about the evaluation metrics we had and the results. So we also used another ensemble, which was weighted ensemble. The first one was the average ensemble model, and the second one was weighted ensemble model. So what happens in weighted ensemble model is we gave weights to the we gave more weights to the one which had higher priority. So we prioritize models based on their accuracy. So the first two models were given 0.4 and 0.4 as weight, because those two gave us the best accuracies. And the last model, Exception, was given 0.2 as a weight. So that adds up to 1. And then we did a weighted ensemble learning of these three models after the weights were given assigned to each one of them. And we got about 97% of an accuracy for the weighted ensemble. And so, yeah, so these were the results. We got 97 and 98% of the models, and the classification was done like efficiently on these three types of SANs. So this is conclusion. Basically, the classification of a SAN is very important, as it helps to reduce the human effort in this process by dividing the SAM depending on its quality, and it speeds up the construction work process of the building or anything that is being constructed. The results have demonstrated with the classification done on the data side has been successful with acceptance accuracy of 98% attained using our ensemble model. And these are the references basically we used for our research work. So thank you, everyone.
I'm very happy to be here today, and thank you very much for attending my presentation. My presentation is about integrating supply chain management with entrepreneurship. So this is pretty much an exploratory study. So the idea here is to actually, this is the presentation outline. So what I'm trying to do is to link supply chain management with entrepreneurship and present a few case illustrations and then propose ways of how supply chain management can contribute to entrepreneurship. And where do we go from here? I will be talking about my future follow-up research on this topic. So basically, the objective of this study, I have two objectives. One is to discuss how supply chain management can contribute to entrepreneurship in the context or in the sense of opportunity identification, and then examine how startups can improve their supply chains to scale up their businesses. For our audience who are not familiar with supply chain management, since I'm in the School of Business and most of the audience seem to be from computer science. And so just to be on the same page, so to speak, and to familiarize ourselves, this is a picture of what we mean by a supply chain. So the main company, like a car company or a clothing company or airplane manufacturing company, is the company that is making the final product. And they have suppliers of raw materials, which supply components, supply the raw materials to the component manufacturer, and then to the main manufacturer. So, and then the main manufacturer would actually send, they may or may not use distributors or as well as retailers, or sometimes they could directly to the end product customers. Or they could be using a combination of all of these. So this is what the supply chain looks like. Of course, the products are moving from the left to the right, and then if there is any recycling or returns, it will be moving from the right to the left. And in the middle of all of this, there is a transportation, storage, logistics, payments, planning, information. All of these activities are used to link all of these members of the supply chain. So a few years ago, supply chain management was not linked to entrepreneurship. Entrepreneurship had basically been disconnected from supply chain management. So here what I'm trying to do in this research is to link them together. So entrepreneurship basically is actually gaining a lot of traction, a lot of attention, and it's the ability to find and create new opportunities with the courage to act on them. And I put these in red because action is the most important thing. A lot of people have ideas, but entrepreneurs put them to action and make them happen in the real world. Entrepreneurship also is very, very, very challenging because you have to do much more than seems imaginable with much less than seems possible. So there is a huge challenge there. And the mindset positions entrepreneurs to identify entrepreneurship opportunities. So the mindset here is very, very important as well. Idea generation is the first step towards finding a strong opportunity. And of course, this is where supply chain management will come in, is in the process of generating ideas. And in entrepreneurship, the more ideas we generate, the greater the likelihood we'll find a strong opportunity. So the number of ideas is also very important. Traditionally or typically, ideas for entrepreneurs can generate ideas in many, many different ways. Here's a list of, it's not an exhaustive list, is the most common ways of generating ideas. Sometimes it's just we kind of observe what's going on in society and identify problems. Sometimes we recall a problem that we have seen before and we can actually brainstorm some ideas on how to solve it. Sometimes we use our imagination. Sometimes we talk to people and the interaction generates ideas. All of these are, sometimes it's generated through research and development and scientific discoveries and invention. All of these are very much well-established idea generation strategies that will end up in opportunities for entrepreneurs. One thing that has been growing, and it's quite new and it's growing very fast, and this is the focus of my research, is actually using supply chain management for opportunity identification for entrepreneurs. So to be clear on the terms that we use, we identify opportunity, we define opportunities as an apparent way of generating value through unique, novel, or desirable products, services, and even processes that have not been previously exploited in a particular content. So this is actually very important here. And it has to have economic value as well. And obviously, more and more we see that ideas for entrepreneurs, especially social entrepreneurs, have social value or environmental value. And so identifying SCM problems that potential customers or any member of the supply chain is currently trying to solve is where the focus is here. So what we're trying to do is we're trying to look at an entire supply chain and identify problems in the supply chain that will actually be the source of ideas and solutions. And solving this problem is actually where the opportunity recognition lies. So for example, you have a graphical illustration of a supply chain. So we have warehouses, factories, information systems, distribution systems, logistics, stores, customers, suppliers. All of these are linked together. And anywhere in the supply chain there could be a problem or an opportunity. The opportunities lately have been mostly in the information systems, developing AI solutions, developing some kind of software applications, and sometimes even restructuring and redesigning the entire supply chains, better ways to reach the customers, logistics ideas. So anywhere you look in the supply chain here, anywhere there might be a problem, there will be a solution that could be the source or the start of an entrepreneurial opportunities. So what we're saying here is that entrepreneurs looking for ideas, they can analyze the supply chain, they can look for where are the most important problems, the most profitable problems, and those problems are where the focus should be and where entrepreneurs could be trying to develop solutions and ideas to solve those problems. And that's what we mean here. So let's look at some examples just to see what this is all about. So Warby Parker, founded by 4 university students in 2010, is an eyewear startup that disrupted the traditional eyewear industry by adopting a direct-to-consumer model. So it is vertically integrated as it designs, produces, and sells its own products. So this allows the company to have greater control over the supply chain, reduce costs, and improve delivery times. So here with Warby Parker, what they did is they looked at the eyewear supply chain, and they basically collapsed it together, and they vertically integrated to give a better product, better prices, better service to their customers. So that's how they use the supply chain to come up with this business model, essentially. Zipline is totally different. It was founded by Keller Clifton in 2014. It delivers medical supplies and blood to remote areas in Africa using drones. So here the focus is logistics. So it is able to, and it's essentially, it looks like a very good example of a social entrepreneur. It is able to bypass traditional supply chain constraints such as poor road infrastructure and deliver supplies quickly and efficiently. So the company has already made a significant impact improving access to medical supplies in underserved areas. So here with the Zipline, it's an example of how they used logistics to solve logistics problems using drones. And at the same time, it has this very, very important social impact at the same time. The last example is Casper. It's a direct-to-consumer mattress company based in New York City that has disrupted the traditional mattress industry. The company recognized that the mattress buying process was outdated and inconvenient for consumers. So the company uses a network of manufacturers and warehouses to deliver its product directly to consumers, eliminating the need for physical retail locations. So again, here they understood, they analyzed the supply chain for mattresses, and they restructured, they redesigned it to give a better service to the consumer. So as you can see here, these are case illustrations on how entrepreneurs or would-be entrepreneurs can analyze the supply chain for a particular product or industry and identify opportunities to solve a particular problem or to provide value. And that could be the startup, the business model, the basis of the business model for the startup. And this is another way. So we're claiming in this research that this is another way, we're not saying it's the best way, but it's a new way of actually coming up with more and hopefully more successful ideas for startups. Another way that supply chain can contribute to entrepreneurship and to startups is to help them perform a better, more successful scale-up by reducing costs, optimizing the process, streamlining logistics, mitigating risk, and minimizing waste. Unfortunately, and as well as sustainable practices, such as, for example, better packaging, environmentally friendly packaging. Unfortunately, supply chain managers, from my research, I noticed from a few cases and interviews that I have done, which are not ready yet for publication, but I noticed that the supply chain managers, entrepreneurs have not enough background sometimes in supply chain management, so they underestimate the importance of supply chain management in scaling up, in managing the business, the operations, the logistics, the suppliers, the procurement, mitigating the risks, and so on. So, and the SWOT analysis is very well known in general for strategic planning, but what I have done here in this research is try to adapt SWOT analysis to supply chain management for entrepreneurs. So here, what we are claiming is that entrepreneurs should focus on supply chain strength, supply chain weaknesses, opportunities, and threats. So strength could be, by understanding their strength, they can build on them, such as strong relationship with suppliers, strong technology, advanced technology. They should identify their weaknesses, such as poor inventory management. They should identify supply chain opportunities like new technology, maybe some geopolitical shifts or new labor laws that could be the start of new opportunities. And also they have to mitigate their risks. So supply chain threats are basically potential risks that have to be identified, evaluated, and mitigated, and as well as monitored. Things like logistic disruptions, geopolitical instability, currency fluctuations, and labor issues, and even change in regulations, which could be sometimes a source of risk and threat. So where do we go from here? Essentially, this is an ongoing research that is basically the contribution is conceptually, but in the process, I'm working on a qualitative research designed to be able to develop case studies of successful startup companies that have integrated supply chain management entrepreneurship. To do that, I am in the process and I will continue to do semi-structured interviews with entrepreneurs to gain insight on how they have integrated supply chain management and entrepreneurship to create successful startups. And in conclusion, an implication for entrepreneurship. So research on entrepreneurship should not underestimate the importance of supply chain management in new venture creation and its scale up as well. And we definitely emphasize that here the importance of a deeper understanding of supply chain management by and for entrepreneurs. So entrepreneurs can build and use their knowledge of supply chain management to identify opportunities and also to expand their business successfully. What I have not done yet also in this study is, before I finish here, is that I have not looked at yet specifically on how entrepreneurship can help supply chain management. That's the other side of the integration. So I looked at one way, which is the contribution of supply chain management for entrepreneurship, but not the other way. The other way is basically the focus of my next study, not this particular study. Thank you very much, and I will welcome all of your questions and inquiries. Thank you very much.
Hi, everyone. Good morning from Zurich, Switzerland. So my research is in the field of economics and finance. It's what we do in finance is that the analysts, the stock analysts, investment analysts, they always make this forecast about the company future earnings, and it hasn't been very accurate. So that's a problem in the field of finance. There's always some kind of surprise. And that's how we see the stock market going up and down a lot. So this research is an outcome of that, trying to understand these errors, where do they come from? And my hypothesis that maybe it's the shortcoming in us as humans in general. So here's the background. So in all economic theories, we assume that when we make these consumption decision, when we buy a house, get a job, study, do research, we go through a very rational decision making, collect all the data, and follow through even on tough decision. We don't delay when something's bad, we don't want to do it, we just do it. We always make rational decisions. So that's the foundation of all economic theories. But in reality, in his book, John Maynard Keynes in the 1930s, this is the most influential economic book. And it says that people actually are not rational. I think all of us, you can think of a few things that we do that are not rational, that not always follow logic. And therefore, he said, because of this, that's how we have these economic cycles. That's why we have this recession, we have economic boom, even though, in fact, it should not be the case. So because of that, Keynes say that the government then play a big role. And this is a foundation of all the government around the world. We still do that today, which is, to intervene when the market is down, when the economy is not so good, the government will try to stimulate the economy by reducing tax or increase government spending. When economy is slowing down, they try to reduce tax or increase government spending to kind of stimulate the economy. So, but in the end, the premise of Keynes' theory is that people are not rational. So what happened is that after Keynes' theory came out, the book came out, a lot of economists tried to formalize Keynes' theory. So they start putting in all these mathematical model equations, which become what we see in economics today, that is very mathematical, all these numbers and equation trying to predict future behavior. So in that process, we kind of lost the premise of John Maynard Keynes that people are actually not rational. Because when we get into mathematical, we're using all the models, just like in other presentation you see in physics and science, there's no emotion involved, right? You just go with the numbers, you go with it, and whatever outcome it is, you just do it. And when economics transform into that, we kind of lost that behavioral part. We start assuming everyone's rational. But then again, as you know, we're not rational, right? When we face uncertainty, we take easy way out. We do something that we shouldn't have. We know what the right thing is. We don't. We just, take the easy path, for example. So in finance, what we'll try to do is we kind of like stay away from economic assumption that people are rational, and we try to understand the behavior of people and see how that affects the phenomena that we see in the real world. Actually, I have some interesting example, to prove that people are not rational. So here, these are the statistics on organ donation in European countries. I don't know, you can see on the screen. So there are a lot of countries that virtually no one donate organs, like Denmark, Netherlands, UK, Germany. But in the other group of countries, Austria, Belgium, France, Hungary, Poland, Portugal, Spain, almost everyone donate their organs. So for a long time, people trying to analyze what's going on. Is it because of geographic distribution, because of culture, because of all the language? And we could not come up with an explanation. Eventually, we look at the form when people fill up when they try to apply for driver license. In Denmark, Netherlands, UK, and Germany, the form say, if you do not want to donate your organ, you have to check now here. So what happened was that, okay, I'm sorry, is you want to donate. So because the form make people do something, I'm just trying to get a driver license, right? So, organ, I'm just gonna not do anything. And therefore people in Denmark, Netherlands, UK, Germany end up not donating the organ. In Austria, Belgium, France, and Hungary, on the other hand, these countries, on the form, it says that if you do not want to donate the organ, you have to check here. So people have to do something, right? So in the end, these people, I don't care, I'm dead anyway, right? So I say, okay, that's why all these countries, people end up 90, 100%, all of them donate the organ because, they were lazy, they didn't pay attention. So that's one example of the fact that people are not rational. And if you look at the, investment field, we found out that the more investor trade, they become very confident about their ability, the poorer the performance. They're not doing so well at all. So in this case, you got examples in the real world that people are not rational. And recently, Kahneman, the economist who just won Nobel Prize in economics, he said, he kind of formalized that idea that people are not rational, saying that, we just make decisions based on these thoughts and patterns that are already there, easy to find, easy to access. We're not going to go and do a lot of work trying to get more information to make this decision. So he came up with the term, what you see is all there is, which means that us humans, we just make decisions based on what already observed, instead of going out, digging more data and do what we're supposed to be to really answer the question. So this is like the foundation of behavioral finance. So going back to my research, my question is that these analysts, when they make these forecasts, so what they do is that 12 months ahead before the next year profit, the data will come out, they will make some kind of forecast. And it's a long time, 12 months, you don't know what's gonna happen. Economy could go really bad, could go very good, inflation, or maybe some more pandemic happen. So there's a lot of data that need to dig in. the question is, do they do it the proper way, getting all the data they need, or they just go with the sentiment? So in finance, we have measurement of stock market sentiment, whether people are really excited or not so excited. And the question is, all these forecasts, are they affected by market sentiment at the time when they make the forecast 12 months ahead, when you don't have a lot of information? So that's my hypothesis. If the people are rational, I will not find anything. There'll be no relation between the forecast error and the measure of market sentiment. It'll be just random. So no relationship. On the other hand, if analysts are influenced by, market sentiments, meaning they have biases, they're not rational, then you see a positive relation. Meaning when people are excited, the market's going up, the bias will be on the high side. When people are afraid, investors do not want to invest, then the errors will be on the conservative side. So that's empirical relationship that I'm starting to collect the data. The first sample I'm doing is in the US, but I do have the data for all the markets in the world. Eventually, I'll get to those countries later, but I start now with the US, presumably very sophisticated market with all the professional analysts. Let's see how they do. So the key variable is the scale forecast error, which measure the forecast 12 months to the actual earnings. And the idea is that if the errors is high on the positive side, meaning the analysts are too optimistic, then the scale forecast error will be positive. If analysts are pessimistic, they're afraid of the future, they underestimate the earnings, the SFE will be negative. Okay. So I just run the regression with two widely used sentiment forecast, the PB, which is the price to book ratio. If the price to book is high, it means the market is very excited, high price compared to the book value, and same interpretation with the earning to price. Sometimes people call it PE ratios. So again, if the analysts are rational, we should not see any relationship. It just be no relationship between price to book and earnings and to price with the sale forecast error. Everything else is kind of control variables. So here's the results. I just want to wrap this up quickly. I think I'm running out of time. For the 12-month errors, forecast errors, you notice there are big relationships, very strong, significant relationship between market sentiment and the forecast error. But here's an interesting part. If you look at a 2-month forecast, which is kind of like almost the end of the year, so everyone already has a lot of data, there's no relationship. So it actually shows that in the end, analysts do exhibit behavioral biases. They tend to be too optimistic, forecast a lot of positive earnings when the stock market was doing well. They tend to be pessimistic when the stock market's not doing so well, on average. So, but in the end, once you look at the short-term forecast, because now it's very short time horizon, they become very accurate. So the biases go away. But for the long horizon forecast, that's not so true. So in the end, we kind of suspect the fact that the errors are associated with the market sentiment. It means that, analysts are just a lot of time making random guesses, and they were influenced by the stock market sentiment. So what's the implication? Again, now we have to be very careful about long horizon forecasts. It's a practice in all countries that a year from now, they're going to make forecasts of all these companies, Apple, Shell Oil, Microsoft. And most of the time, you're going to find them to be incorrect. But here's the thing, you can actually trade on this. If you understand which market sentiment affect the forecast error, make it high or low, then you can find possible mispricing and maybe trade and make profit out of that. So that's my research. Thank you very much.
Before I start my presentation, I'm happy to present to you. My name is Hossam Al-Hamadi. I'm a master's student at Biomedical Engineering in Fatih Sultan Muhammad University at Istanbul. And our presentation, it would be artificial Alzheimer EEG data set generation using generative adversarial networks. It has done by Hossam Al-Muhammad, Mohammed Nasser, and Abu Bakr Kuch. Before I start my presentation, I will give you a background about Alzheimer's disease. Alzheimer's disease is a progressive neurologic disorder that causes the brain to shrink and brain cells to die. This diagnosis by this disease diagnosis by Dr. Olius Alzheimer in 1907, and it thought be caused by abnormal protein around the brain cells. This is one of this protein called amyloid, and this is make plaques or interrupt the connection between brain cells. It's a serious problem over the world, especially in United States, which is caused the third most costly disease and the sixth leading to the death. And by 2050, Alzheimer's dementia is expected to affect 12.7 million people in the United States. As we said, like AD, Alzheimer's disease is incurable disease, and I think its early diagnosis is the most important method to increase the quality and quantity of patients' care. Several methods such as biochemical markers and image biomarkers and EEG has contributed to diagnose this disease. And EEG, it has been access abnormal brain patterns related to Alzheimer's disease in the cortical level for low-cost, non-invasive, and portability. And Alzheimer's disease are checked in EEG pattern as refers its name EEG slowing, which is increased the power in low frequency patterns such as theta and delta, and decrease the power in decrease the power in high frequency patterns such as beta and alpha. As also I said before, there is currently no proven treatment method for patients who enter a Alzheimer's stage. And presently, doctor and neurologists and medical experts still make manual diagnosis, and sometimes for one case it takes from then several hours to reach final results. So deep learning method, it is a promising approach in this field. However, it requires large data set to learn and give accurate results. While obtaining EEG data from Alzheimer patients, it's problematic. Sometimes researchers spend a lot of time, money, and effort just to obtain data, and sometimes this data contain noise and not mention patients' right policy. So our group to address this issue, we have present EEG Alzheimer's disease signal generation approach based on generative adversarial network to facilitate an accessible artificial EEG Alzheimer's data set. So we will jump to material, which first EEG model must employ real data set to generate artificial data set. So a data set comes to taken from two Temple University Hospital are collected, and this contain data set as experts from the Temple University Hospital, and also one specialist from the Kartal University in hospital in Istanbul are engaged to ensure this data set contain Alzheimer's disease. A set from 44 subjects, around 20 patients, as we can see in the table, have been used. And also, as usual, EEG contains, and we have been used MNE package has processed the data set to eliminating interferencing and removing ocular artifacts and ocular artifacts and AMG signals. And also our project, our work are limited to 4 channels due to Alzheimer's disease is more pronounced in the occipital and temporal region of the brain. Now we will move to GAN model. GAN model is consists two models, generator and discriminator. Generator model is responsible for generate a new artificial Alzheimer EEG signal. It feeds by noise and 8 layers, as we can see, and the output it would be artificial EEG signal. Now we will move to discriminator. Discriminator model is responsible for distinguishing whether the signal is real or artificial. We have been used BGG 16 as well known convolution neural network with 16 layers, 13 layer convolution layers, and 3 fully connected layers. Now that's our block diagram. First, I will just make a short view about it. First, the discriminator are defined. The data is defined to discriminator, which is real and generated and trained. After that, generators start to transform this noise to artificial EEG signals and feed to discriminator. The discriminator purpose is to distinguish or just to detect which the data comes from real or from generated. Suppose now the discriminator just detect this data it's come from generated. There is a feedback. The feedback goes to generator to adjust and enhance and adjust network to generate artificial signals that cannot be detected by discriminator. Now our result, like after we have like data set have been processed and channel are divided, and every channel are trained like around 10,000 epochs individually. After that, we have been used some tested on them. One of them, this named spectrum entropy and reconstruction error, which is spectral entropy is a statistical measure that evaluates the randomness or complexity of signal frequency spectrum, and the reconstruction error, it measures the differences between the values and original signals and reconstruction. This method, this matrix have been used before to test or to measure the performance of GAN model, and we can see from generated models we have two of them are succeed. One of them GAN Alzheimer 1, and it's better than GAN Alzheimer 2. As we can see, the spectral entropy differences between the artificial dataset, the Alzheimer dataset, and our artificial dataset is around 0.048. Also, we have used the frequency domain to examine the similarity between the artificial and the real signals. As we can see, the real signals has 67 peaks, while the artificial has 63 peaks, reinforcing that model efficiency in generating the signal associated with Alzheimer's disease. We can discuss thus that our model have achieved high accuracy, which generate a slow wave in this like 3 channels like T501 and T602 and B402, like in 5 to 7 hertz. And sometimes like in this channel B301, the frequency range increase from 7 to 10 when it is for longer sessions. Like this is for normal, and this is our artificial generator signals. We can conclude that deep learning is powerful tool that help us to better understand EEG features. This paper proposed generated artificial Alzheimer EEG signal using generative adversarial network. We can leverage GAN to generate artificial Alzheimer EEG signals from noise. Based on the results, our method is characterized effectively in generating Alzheimer signals. Our future direction include developing methods that generate Alzheimer signals at all stages with the possibility of controlling the properties of the generated signals. That's all. Thank you for listening. I'll be happy to answer your
of our project is the roadways are used for the roadways is the most used system for the traveling, and it's actually convenience. Speed is very good, and that's why we actually use roadways. But actually we face the accidents in the traveling, and for that we have created a system for avoiding the accidents. So, the problem statement was to develop the model to minimize or to decrease the accidents, and to also to inform the victim's family that even if there's a rash driving or etc. The objective of our project is, the main objective behind it is accident, to minimize the accident and make it less likely. Actually our system recognizes the rash driving even if the vehicle is accelerating like abnormally, and it is detected by the sensors in our system. In methodology, I'll tell about the components we have used. So first is Node MCU, that is also known as ESP8266. This is a microcontroller, and we use this microcontroller for sending an email to the email, and also live location to the like to the owner's mail ID. And also we have used MPU 6050. This device is actually accelerometer, gyroscope and accelerometer sensor, and it actually detects if there is some abnormal speed up in the vehicle, or is there is something like unbalanced in the axis. Actually it detects, it works on 3 axes, X, Y, and Z axis, and if there is abnormal driving or any rash driving happens, it sends the alert message on display, and then if it continues, it sends the email to the receiver, to the owner, like at the mail ID. Next is Neo 6M GPS module. This is a GPS module. If we have installed in our system for sending the live location of the driver, because if any accident happens, the it will be sent, mail will be sent, and the live location with the Google Maps, like actual GPS map, will be shared to the email, and they can track the location of the vehicle. This is the circuit diagram of a system. So here we have a display, LCD display, and the alert message will be displayed here. Or there is no rash driving, then it will simply display safe driving or normal driving. And here we have installed Node MCU, that is ESP8266. For that, it actually works. It is actually a Wi-Fi module, and it works on Wi-Fi hotspot. So it can be operated wirelessly. So that's why we have used this. And then we have the GPS module for the location, and here we have accelerometer and gyroscope sensor for the like rash driving detection. So yeah, these all are the components I have just explained. This is the LCD display, and here the message will be first shown, and then it will be shared to the email. So the literature, these are the some papers which we studied for before our project, So they are accident prevention system, prevention and safety assistant using IoT and machine learning, then IoT based framework for the detection of vehicle accident, and IoT based system for accident detection and prevention, vehicle tracking and accident notification system, and etc. So the result and conclusion of our project is like we need to prevent the accident or to minimize the accident, and that's a primary goal. And the next is like we need to inform the, if it's accident is happened, then we need to inform it to the victim's family. So that's the secondary goal. And another email will be sent to informing that to the recipients, like whichever emails are given at that time. And also it also sends an email if the driving is like a driver is not driving it correctly or recklessly. So yeah. Next is a future scope for our project. So actually we can use this project, this model in and we can actually add some add the mail ID of police or ambulance or maybe call. So it will automatically reach to the police or ambulance, and that will be more safer option. Then the victim will primarily like cured. Then next is we can add some more sensors that will detect the eye movement of the driver. If he's not blinking, he has closed eyes or anything else, and also detecting yawning or detecting toxic gases, alcohol consumption to prevent the safety of the driver. And also this system can be include wireless webcams that can be mounted back of the vehicle to capture images that will aid in providing driver's assistance. And these are the references we have taken. Thank you.